The next step in modeling the bottle is to add an indented area on the label faces where the label will be applied. Generally speaking, best practice guidelines recommend that you don't make features dependent on fillet edges. Of course, there are some exceptions. In this case, for instance, the edges of the fillets added in the previous step help define the area that's available for the label. This is why the fillets were added before creating the indented label faces. To create an indented area for the label, I'll be creating a cut, starting with a new sketch on the right plane. Activating the right view makes it easier to work on this sketch. Then I'll select the visible label face and use the offset entities to make a closed loop sketch at an offset of 0.25 inches. To break the sharp corners, I'll use the Sketch Fillet tool to add half-inch fillets. Next, I'd like to smooth out this entire contour by using the Fit Spline tool. This is a technique you can use to convert a chain made up of multiple sketch entities and replace it with a single spline. When the resulting contour is used to create a feature, such as a cut in this case, the edges of the cut will be smooth and will lend themselves well for draft and fillet features. To use the Fit Spline tool, I'll first select the geometry I wish to convert. Using the Select Chain command is a convenient way to do this. Now I'll launch the Fit Spline tool from the Tools Spline Tools drop-down menu. I'll set the tolerance to 0.05 inches and click the green check. There are a couple of things to note about the Fit Spline tool. First, you must click the green check to complete the function. The Fit Spline tool doesn't work like most other commands. If you set the tolerance and then press Enter, SOLIDWORKS exits the tool without applying it. Also, if you accidentally entered the wrong tolerance value, you cannot go back and change it. Instead, you'd have to delete the spline and recreate it. The current sketch is on the right plane, but the material I need to remove is on the outer face of the part. To accommodate this, I'll set the From Start condition to Offset, with an offset distance of 3 inches. I'll then set the End condition to be Offset from Surface, selecting the label surface as the reference. I'll make sure to use the Reverse Offset option because I don't want the cut to stop short of the label face, but to cut into it. The offset distance should be 0.1. I need to apply heavy draft to the walls of the cut, but I won't draft in the cut feature itself. This would result in a draft angle measured from the sketch plane, in this case the right plane. Instead, I'll add a separate draft feature to create draft with the proper angle. For now, I'll click OK to complete the cut. Now eventually I'll want to mirror this cut, along with the draft feature and a fillet. The mirror feature cannot mirror all three of these items together. I'll have to mirror the cut feature first, and then create separate draft and fillet features. To mirror the cut, I'll initiate the mirror feature. I'll select the right plane as the mirror plane, and activate the Features to Mirror selection box. The feature I want to mirror is the extruded cut, which can be selected either from the Graphics window or the Feature Manager. I'll then make sure to enable the Geometry Pattern option. Geometry Pattern mirrors only the finished feature geometry, rather than mirroring the parametric intelligence of the feature. For example, in this extruded cut, the End condition is Offset from Surface. If we simply mirrored the feature, it would cut through the part to the selected face on the other side, in effect mirroring the Offset from Surface End condition. Unfortunately, the Geometry Pattern option will not work if the draft and fillet features were present, so they must be created separately. Once the mirror is complete, I'll start the draft feature on the side of the original cut. First, I'll set the type of draft to Parting Line Draft and set the draft angle to 30 degrees. I'll select the right plane as the reference for the direction of pull, making sure the arrow is pointing toward the original cut. And finally, I'll select the edge around the outside of the extruded cut feature and click OK. Since the draft feature cannot be mirrored, I'll recreate it on the other side. All settings for the second draft are the same, with the direction of pull set to the opposite side. The remaining step for completing the label inset is to break the sharp edges with a fillet. Now, the fillet feature might be tricky if it were not for an underused but very useful option in SolidWorks, the hold line. Since the angle between the adjacent faces changes around the perimeter of the label cut, the fillet might be too large in some places and not large enough in others. A face fillet gives us the option to use a hold line, which essentially specifies exactly where the edge of the fillet should be. I'll launch the fillet feature and select the face fillet type. I'll choose the faces I wish to blend, and activate the hold line selection box. In this case, I can specify that the fillet being added should end exactly at the inner edge of the cut. This is basically a variable radius fillet, where SolidWorks automatically adjusts the fillet to stay within the specified boundary. Notice that as soon as a hold line is selected, the radius value box disappears. This is because the hold line edge is driving the fillet radius. In this way, the drafted face is completely removed by the fillet feature. I'll repeat the face fillet on the other side.